So hello everyone, welcome to the channel. So in this video, I'm gonna show you the day and night urban land surface temperature analysis using MODIS dataset in Google Earth Engine. So now let's get started. So the urban land surface temperature analysis is critical for understanding the thermal dynamics of an urban and natural environment. The thermal behavior of land surface varies significantly between the day and night due to a difference in the land cover, human activities and climate conditions. Monitoring the LST is essential for studying the urban heat island effects, environmental changes, and water body temperature fluctuations. The remote sensing data, particularly from the moderate resolution imaging spectroradiometer, provides a comprehensive and consistent measurement of LST over the large geographic areas. The Google Earth Engine, with its vast geospatial dataset and cloud computing, offers the efficient platform for a large scale LST analysis. So this study focuses on analyzing the day and night urban land surface temperature trend using the MODIS dataset from 2004 to 2024. So by examining the variation over the water bodies in urban areas, this analysis aims to provide an insight into heat distribution patterns and their implication on urban climate. So let's get started. So let us define our region of interest. So to define our region of interest, we're going to use this variable called, we're going to create a variable called ROI coordinates equals to, so we're going to specify the latitude and longitude. So to create a region of interest, so we're going to navigate this option called add a rectangle. And now we're going to click this and I'm going to draw my region of interest over my desired study region. For example, so I've selected this particular study region called New York, so you can able to see that. So once you created your region of interest, you can navigate this option here and click this option called show generated code. So from here you can copy the latitude and longitude of your study region and copy it and paste it in this variable called ROI quads, represents region of interest coordinates. So you can paste your latitude and longitude to create your region of interest. So I have already created my region of interest, so I'm going to delete this. So once you copied and pasted your latitude and longitude, next we're going to convert this particular the coordinates into a polygon. So to do that, we're going to define a variable called a region of interest equals to earthengine.geometry.polygon and ROI coordinates. So it's going to refer this particular variable containing the latitude and longitude. So it's going to convert it into a polygon. So for that, we have defined the variable region of interest earthengine.geometry.polygon. So we are converting this coordinates into a polygon. So next, to center this study region, we're going to define map.center object region of interest referring to our study region. And to add this layer, we're going to define map.addLayer region of interest, and you can specify in the visualization parameter, you can specify the color of your choice. For example, I've stated the color as black, and we're going to output the layer name as study area. So you can navigate this option in the layers section here. I'm going to turn on my study area. So now you can able to visualize we have created our region of interest. So next data is we're going to load our MODIS land cover data. So next we're going to load our MODIS land cover data. So let me explain about this particular data set here. So the MODIS land cover data early global of 500 meter resolution. So the dataset availability is from 2001 to 2023. And the dataset provider is NASA. So using this particular code, you can access this MODIS land cover global land cover dataset of 500 meter resolution. So the resolution of this particular data is 500 meters, and we have different band that is available for in this dataset here. So we're gonna specifically select this particular band of LC type 1. So land cover type 1 annual international geosphere biosphere program IGBP classification. So we're going to select this particular band. So let me get back to Earth Engine. So to load our, so in order to access the MODIS land cover dataset, we're going to define a variable called MODIS land cover equals to earthengine.image collection MODIS 061 MCD1 2Q1. And in that we're going to apply this particular function called .mode function. So this function basically computes the most frequently occurring value for each pixel across all images in the collection. For example, so it is used to reduce the data variability and highlight the most consistent land cover classification over time. So in order to acquire a mode, a land cover type, or we can say a consistent land cover classification. So for that, we are using the specific function called dot mode function. So in this dataset, we're going to specifically select this particular band called LC type 1. So to select that, we're going to define dot select LC type 1. So next, for visualization purposes, so we have to define the visualization parameter in order to view the image or the land cover image in different color contrast. So for that, we have to define the visualization for our land cover data. So we're going to define a variable called land cover visualization, and we're going to set a minimum value of 1 and to a maximum of 17 based on the total number of land cover classes. For example, so this particular LC type 1 class has a total of 17 classes. So for that, we are defining the minimum value of 1 and to a maximum value of 17 to represent the 17 different types of land covers. And next, to add this layer, we're going to define map.addLayer modis land cover dot clip. So we are using the clip function in order to view the land cover image of our region of, that is for our study region. So for that, we are using this function dot clip and referring to our study region, that is region of interest. And the land cover visualization refers to the visualization parameter in order to visualize the image in different color classes for the land cover data and output the layer name as land cover. And next, we're going to extract the water bodies. For example, so in our study region has both urban and urban area, as well as we have some water bodies. So in order to view the land surface temperature separately for the urban areas, as well as the land surface temperature on different temperature on the water bodies, so we're gonna separate the urban and we're gonna separate the water bodies, and we're gonna take the data for the LST for the urban areas as well as the LST for the water bodies during day and night as well. So for that, we're going to define this particular, we're going to extract for the water body. So water body in MODIS land cover, which represented in class 17, that is water bodies, at least 60% of the area is covered by the permanent water body. This is the class called water body. So to extract the water body, we're going to define the variable called water mask equals to MODIS land cover data. So we are referring to land MODIS land cover data set, and dot equal, so MODIS land cover equals to 17 which refers to water body. So we're going to update mask. So dot equals to 17, so 17 which represents the water body in MODIS land cover dataset, and we're gonna update this particular in our MODIS land cover dataset. So to extract only the water bodies. So for that, we're gonna define dot update mask MODIS land cover dot equals to 17. So now it automatically updates and it's gonna select only the water bodies. And next, we're gonna define another variable called water vector. So we're going to convert this MODIS, it is currently in raster format. So to convert to a vector format, we're going to define this variable called water vector equals to water mask dot reduce to vectors. So we are reducing from a raster to a vector. So for that, we are using this function dot reduce to vectors. And in the geometry, we're going to define the region of interest, that is our study region. And we're going to mention the spatial resolution of 500 meters. So in the next step, we're going to define as a dot union 1. So we are using the union function. So in order to merge the adjacent water polygons, so while we are extracting the water bodies are the different water bodies, for example, in this study regions might be fragmented. So might be fragmented, and in order to union all those water bodies together, so we are using this function called dot union 1. So it merges adjacent water polygons into a single feature. So to avoid the fragmented polygon and giving a cleaner water body outline. So for that, you are using this function dot union function. So next, to add this layer, we're going to define map.addLayer water vector referring to this particular variable. And we're going to specify the visualization parameter using the curly brackets. So we're going to specify the color, so as a blue, and we're going to output as water bodies. So now let us navigate to the layer section here, and in that, let us first view the land cover dataset. So you can able to visualize here. Currently, we have a different land cover datasets been available here. So we have different land cover classes that is available for the specific study region. For example, So I'm gonna use my inspector tool here. So I'm gonna click on this. Once you click the inspector tool, we're gonna click on this particular land cover class. So in order to visualize what is the land cover type, we are currently visualizing it. So for that, we're gonna navigate to this option here. So here you can able to visualize. We have land cover image 1 band, LC type 13. So let us check out what is 13 represents here. So the 13 which represents the urban and build up lands. So you can able to see that. And we are this particular color which represents the urban class, and next for example this particular color, the green, which represents the LC type 1-4. So type 1-4 which represents the deciduous broadleaf forest, so the class 4 which represents that. So let me get back to Earth Engine. So in this way you can be able to view the different land cover classes that is available in the study region. For example, this particular color which represents the urban area, that is our focus, where we're going to analyze the LST, the land surface temperature during day and night, and also on the water bodies from the study region. We're going to analyze the land surface temperature trend during day and night for an entire period from 2004 to 2024. So to do that, next we're gonna focus, that is we're gonna load and process the MODIS LST data, the day and night dataset for over a period of 2004 to 2024. So first we're gonna define a variable called LST day, that is land surface temperature day equals to Earth Engine dot image collection MODIS 061 MODIS 11 A2. So first let me explain about this particular dataset. So MODIS Terra land surface temperature emissivity 8-day global 1 kilometer resolution dataset. So this particular product provides an average of 8-day land surface temperature in a 1200 by 1200 kilometer grid. And let us take a look at the bands that is available in this dataset. So the dataset availability is from 2000 to 2025. And the dataset provider is NASA LP, and this particular data can be accessed using this particular script here. So using this code you can access this LST dataset of MODIS. So let us take a look at the bands that is available. So the resolution of this dataset is around 1000 meters. So we're going to specifically use these two set of bands here. For example, this particular band is LST in day 1 kilometer, and unit is represented in Kelvin. And these are the minimum and maximum values, and this is a day land surface temperature. And similarly we're going to view another band that is LST night 1 kilometer. So it is units also similar, it is Kelvin, and the minimum and maximum value, and it is a night land surface temperature. So we're going to use these two bands, that is LST day 1 kilometer and LST night 1 kilometer. So in order to analyze the land surface temperature during day and night for an entire period from 2004 to 2024. So let me get back to Earth Engine. So to do that, we're going to define variable LST day equals to Earth Engine dot image collection, and make sure they specify the code. And from that, we're going to select this particular band. So that is, I have already mentioned. So we're going to select this band called LST day 1 kilometer. So to select, we're going to define dot select function LST day 1 kilometer. And we're going to filter with the specific timeline from 2004 to 2024. Make sure that you always check for the dataset availability date. So the dataset availability is from 2000 to 2025. So we are specifically focusing on from 2004 to 2024. So I'm going to filter based on this particular timeline. To do that, we're going to define dot filter date 2024 January 1, 2024 December 31. And next we're going to create a loop function. So currently the LST is in Kelvin, so we have to convert it to in degrees Celsius. So to do that, we're going to define a function. So we're going to create a loop function. So for that, we're going to define dot map function image referring to our dataset, and we're going to return the image dot multiply 0.02 dot subtract 273.15. So basically it converts our Kelvin units to Celsius. So we're going to apply this formula to convert from Kelvin to Celsius, degree Celsius. So next, in order to copy those properties into this image, we're going to define dot copy properties image and image dot property name function. And similar, we're going to define a variable called LST night So in order to visualize the land surface temperature during night time, so we are using a variable LST night, and we're going to access the image collection. Similarly, Earth Engine image collection MODIS 061, and now we're going to select a different band, that is LST night 1 kilometer. So to visualize the land surface temperature during night time, we are specifically using this band, and this band has a resolution of around 1000 meters. So first to select, we're going to define dot select function LST night 1 kilometers, and we're going to specify the timeline. So we are already specified in my timeline here. So for that, we can define dot filter date 2004 to the January 1 to December 2024 December 31st, and we're going to create a similar another loop function in order to convert the Kelvin units to degrees Celsius. So we are using the similar function as I said earlier. And next, to conduct a time series analysis for water bodies, that is to analyze the land surface temperature trend for day and night for entire time period from this particular time period. So in order to visualize in the chart, we're going to define as a print in the as a time series analysis. So we can define it in the as a chart. So for that, we're going to define print ui.chart.image.series, and in the image collection, we're going to specify LST day and the region for now. So we are focusing on the land surface temperature on water bodies as well as in the urban area. So to focusing on the water bodies for first thing, and we're going to specify the region as water vector. So in the water vector, so in this study region, it's going to pick up all the different water bodies that's available, and it's going to take all those water bodies, and it's going to give us the mean LST, that is land surface temperature in degrees Celsius over the timeline as specified here, that is 2004 to 2024. So to do that, we're going to define ui.chart.image.series and image collection referring to the LST day. So using that is LST land surface temperature at during day, and the region is water vector, and we're going to apply some statistical function in order to acquire a mean value, for example. So each month has as a LST fluctuates. So in order to acquire a mean value for a month as well as for a mean value for year, we are using the statistical function. So we're going to specify as reducer earthengine.reducer.mean function to acquire a mean LST value for each years. So we are using this particular function, earthengine.reduce.mean function, and we have to specify the resolution. So that is it has a resolution of 500 meters, and we're going to specify the X property, that is system start time. So that is from 2004. So we're going to specify its system start time. And next, you can apply some additional properties to your chart. For example, you can set some title, and you can make some other color of your trend line. So to do that, to set an additional options, we're going to define dot set options, and title we're going to define Daytime LST. So we're going to specify as the title Daytime LST over the water bodies from 2004 to 2024. And the H-axis, we're going to specify the title as year, and the V-axis, we're going to specify the title as temperature in degrees Celsius. And you can also specify the line width to be around 2, and the color of your line, the trend line. So you can set your desired color. So next, we're going to visualize the LST during the night time. So that is land surface temperature over the water bodies during night time. So to do that, we're going to define print ui.chart.image.series, and similar, we're going to refer the image collection, that is LST night variable. LST night, for example, we are referring to this particular variable LST night, and the region referring to our region of interest, that is our water vector, that is which represents our water body. And the reducer, we're going to define as similarly as specify the statistical operation in order to acquire a mean value for LST temperature for each year. So we are using the statistical operation. So we define earthengine.reducer.mean function, so in order to acquire mean LST value, and we're going to specify the resolution of this particular dataset. So for that, we're going to specify as 500 meter of resolution. So this dataset has a resolution of around let me show you that. So this dataset has a resolution of around 1000 meters. So we're going to specify as 500. So you can also increase the resolution of this particular data set, but it takes some increased computation time. So I'm going to specify as 500, and similarly I'm going to specify its system start time. So the date at which it's going to start our analysis, for example at 2004. And as said earlier, the additional options, for example title, we're going to specify as nighttime LST over water bodies from 2004 to 2024. And the H axis represents the year, and V axis the temperature in degrees Celsius, and the line width we can specify as 2, and the color is your choice. You can specify any color of your choice. So now let us take a look at the analysis. So we're going to navigate the run script and click run script. And now let us visualize the result here. So first in the layer section we have our study region. Let me turn off the other layers here. So first is our study region, and next is our land cover we discussed earlier, and next is our water body. Let me turn this off. So now we can able to visualize it is extract all the water bodies separately, and it's going to analyze the temperature of all these water bodies in this specific study region, including our ocean and also the water bodies in the interior, for example in the urban, in the terrestrial lands and land. It's going to analyze the temperature. And next is we're going to visualize, take a look at this particular chart here in the console section here, the daytime LST over the water bodies. So from 2004 to 2024. So LST day of 1 kilometers. And you can able to visualize we have the temperature of during the daytime, the land surface temperature over the water body. So let us take a look here. So now it is more easy to visualize it. So you can able to visualize here during this particular time here. So it has a temperature during the daytime. The LST land surface temperature over the water body was around 27 degrees Celsius for the specific study region, that is in New York in United States of America. So it has temperature of around 27.5 degrees Celsius, that is during the month of July. And similarly, and let us visualize the lowest level of temperature that is observed. So it is around in January, it has a temperature was less than -6 degrees Celsius. So it was around 6 degrees Celsius during Jan, and during July it was around 26.6 degrees Celsius. Comparatively in the next year, so for example the peak temperature that is observed is around 29.6 degrees Celsius during August. So likewise you can click on these different points here and you can visualize the temperature around each month. For example, the temperature has dropped significantly during the December and Jan. So for example, you can able to see the temperature here. It is around 1 degree Celsius, and here it is around 1.3 degrees Celsius. Likewise, we have at LST, the land surface temperature for entire timeline from 2004 to 2024 during the daytime. And similarly, to visualize the land surface temperature during nighttime data over the water bodies, we're going to refer the second chart here. So I'm going to click this option here to visualize it, the LST land surface temperature during nighttime over the water body. So for example here, so during the nighttime, the land surface temperature was around 20 degrees Celsius during July. So and also in 20 degrees Celsius during nighttime. So comparatively, during the daytime, it was around 27 degrees Celsius. And during the nighttime, the temperature has dropped to around 20 degrees Celsius. And here in this case, around 19.97 degrees Celsius, 19 degrees Celsius during nighttime. And similarly here, you can observe here, and during the nighttime, the water bodies in this particular study region, the temperature has dropped to a negative 10 degrees Celsius during nighttime. So likewise, we have the land surface temperature for entire timeline here. You can take a look here, the different trend that is observed. And during a certain years, we have a very drop. The temperatures drop to around -14 degrees Celsius also. And in certain regions, we have temperature of around -3 degrees Celsius. So let me get back to Earth Engine. And now we have managed to identify the land surface temperature over the water body during day and night. And now let us visualize the land surface temperature during the day and night in the urban areas. So first, let us extract the urban areas from our MODIS land cover dataset. So for example, let me close this. So MODIS land cover dataset of class 13, which refers to build up urban and build up plans. So to extract the urban areas from our MODIS land cover data, so we're going to use this, we're going to create a loop function. So we're going to create function extract urban area image referring to a MODIS dataset. And inside this loop function, we're going to create a variable called urban mask equals to image dot equals to 13. So in the MODIS image equals to 13, which refers to the land cover of urban and build up plan. So in order to extract only the urban classes, we are using this image dot equal 13, and we're going to apply the update mask function in order to select only the urban areas. So to do that, we define dot update mask image dot equals to 13. So now it's going to give only the urban classes only, and so it's going to only show us only the urban classes. So where we can use that to analyze the land surface temperature over the urban during day and night. So we can return urban mask dot reduce to vector. So it is currently in raster format. So to increase the speed of analysis, we can convert, and to perform analysis, we're going to convert to a raster to a vector format. So to do that, we're going to define reduce to vectors. And next, we're going to specify the geometry. So this geometry here represents our region of interest. That is our study region. So this is our study region. So we're going to specify the resolution, so around 500 meters. And again, we are using dot union function. So in order to aggregate all the urban class together in a single as a single file. So in order to analyze the entire land surface temperature over that urban areas. So it's very useful in case the urban areas kind of fragmented. So in order to union all together, so we are using this function union dot union function. And next, we're going to define a variable. So next, we have defined a variable called urban areas equals to the extracted urban areas. So referring to this particular function we had defined earlier, loop function. So it's going to refer our MODIS land cover dataset. So basically this particular function we have created earlier, it's going to hold our urban classes of the MODIS land cover data. So next, to add this layer, so to add the urban class only, we're going to use map.addLayer urban areas, and we're going to define the visualization parameter. So in order to visualize the urban area color, so I have selected as an orange. You can also mention it as red here. So in order to view that in red color, so now I'm going to visualize it in orange. So I've specified as an orange, and I'll put the layer name as urban area. So now let us visualize the result. So we're going to navigate to the layer section here, layer section, and we're going to turn on this particular layer called urban areas. So now you can able to visualize we have managed to extract all the urban areas. So once you extracted all the urban areas from your study region, so next we can provide we can proceed towards analyzing the land surface temperature over this urban area during day and night. So I can confirm you that. So I'm going to select the satellite mode here. So I'm going to turn off the study region and water body. So we're going to zoom into this particular study region. So you can able to visualize this is urban area. So you can able to see that it's fully urbanized. So it's currently this particular, it picks up all the urban areas in the study region. So you can able to see that. So our next step is to we're going to proceed towards time series analysis for the urban areas, the land surface temperature for both day and night time. So to perform time series analysis for urban area during day and night, first we're going to define print ui.chart.image.series. So to proceed to create in a time series chart for urban areas, the temperature variations, that is land surface temperature varies during day and night. We're going to mention ui.chart.image.series, and image collection we're going to specify LST day. So LST day which represents that land surface temperature during day, and the region we're going to specify as urban area. So the urban areas, so that is our build up areas. And reducer, we're going to apply this statistical function, that is in order to acquire mean LST value for entire period for each year or for each month. So for that we define Earth engine dot reducer dot mean function to acquire a mean value for each month and year. And next we can apply the scale spatial resolution of 500 meters, and the system start time, which refers to the start time of analysis, is 2004. And you can set your additional options as said previously. The title is Daytime LST over the urban areas from 2004 to 2024, and H-axis is title is year, and the V-axis is title is temperature in degrees Celsius, and the line width as mentioned 2. So you can set your desired color for your trend line. So you are for this lines here, so specify this particular color. And similarly, to visualize our land surface temperature during night, so we're going to define to create time series chart. For that, we're going to define UI dot chart. Similarly, image collection, we are referring to LST night, the nighttime data, and region urban areas, that is this particular orange color. We can specifically selecting on focusing on urban areas to acquire mean LST value. We're using the statistical function earth engine dot reducer dot main function, and the system start time as said earlier, and so additional options. The title, additional options to create in your chart. So title is nighttime LST over urban areas, and the H-axis is title year, and V-axis is temperature in degrees Celsius, and the width, color, line width and color. So next, let us visualize the result. So we're going to navigate to the run script and click run script. So now we're going to visualize the land surface temperature over the urban areas. So now here you can able to visualize the daytime LST over the urban areas from 2004 to 2024. So you can able to visualize this chart here. So let us visualize it here. So you can able to see here the temperatures and the land surface temperature over this particular urban area, that is in New York. So the highest temperature during the 2004 was observed to be around 32 degrees Celsius, and you can able to see that. And the lowest temperature is recorded in this month here, January. So it is around -7 degrees Celsius. And similarly, the highest recorded temperature, so it is around here. So this particular year in 2010, it is around 36.2 degrees Celsius. And the lowest level of temperature that is observed is in this year. It is around January 2018, -10 degrees Celsius. So you can able to see this in this study region, as highest level of temperature being observed is during August and July, and also in September. And the temperature drops after September. The temperature drops significantly during this year. So the temperature is around lowest drop. The temperature was around, the highest level of temperature drop was observed is around -10.6 degrees Celsius in New York, and the highest land surface temperature that has occurred is 36.2 degrees Celsius over the urban areas. So during the daytime land surface temperature over the urban areas. And similarly, let us take a look at the nighttime LST land surface temperature over the urban areas, that is during nighttime. So let us take a look at that. So this is the graph. So you can able to view this nighttime land surface temperature over the urban areas. So the highest level of temperature was observed to be around 21 degrees Celsius during this particular month, July 2004, and the lowest level of temperature is observed to be around this particular month, January, and January 2005, around -12.7 degrees Celsius. And let us take the other lowest is in January. So during the January, the urban areas, during night time, the temperature has been dropped to around -14.5 degrees Celsius. And the highest level of temperature is observed to be here in July, is around 24.85 degrees Celsius during night time during the month of July 2013. So in this way, you can able to visualize the temperature variation, that is land surface temperature over variation during night time over the urban areas in the study region, New York. So now let me get back to Earth Engine. So in the next step, we are to so we're gonna export this particular LST data. For example, so I'm gonna export the 2020 LST dataset to my Google Drive. So to export this particular year, so I've mentioned as 2020. So in case you want to export the different year, you can change the year here. So for example, if you want LST of 2025, you can mention the 2025 year. So for this example, I'm going to export the LST data for, that is land surface temperature data of 2020 to my Google Drive. So to do that, we can define a variable LST date 2020 equals to LST date dot filter date 2020 January 1, 2020 December 31st. So I'm gonna mention the entire time period, and from that entire time period, I'm gonna mention to not acquire mean LST image for 2020. So I've defined this function called dot mean function. So to acquire a mean LST land surface temperature image for this particular year 2020, I've defined this for the LST daytime. And similarly, to export, for example, we're gonna define another variable LST night 2020. So we're gonna export both day and night data. So define the variable LST night 2020, and we're gonna mention LST night referring to our LST land surface temperature image of MODIS image. So it's referring to that variable, and we're gonna filter with a specific timeline. So as mentioned, 2020 January 1, 2020 December 31st. And to acquire a mean image of land surface temperature during the night time, we're going to acquire for this entire period, we're going to mention dot mean function. And to export this image to your Google Drive, we're going to define export dot image dot to drive. So image LST day 2020 dot clip region of interest referring to our study region, and description MODIS LST date 2020, and the spatial resolution is around 500 meters, and region referring to our region of interest, that is our study region, and coordinate reference system, it is EPSG 4326, and you can create a folder as LST export and mention the max pixel value. And similarly, we have mentioned the export.lst for nighttime data. Similar to that, we're going to mention this similarly, like the same as mentioned earlier here. LST night 2020 clip region of interest. Description is MODIS LST night 2020 data, and resolution region of interest, coordinate reference system, and the folder, and the max pixel value. And last, to visualize this image, for example, we're going to visualize the LST land surface temperature for day and night for this particular year 2020. So for that, to visualize, we define map.addLayer LST day 2020.clip. So specifically, we're going to clip on the region of, that is our study region. I've mentioned .clip function, study region, that is region of interest, and we're going to mention the minimum and maximum value. So the minimum value we're going to specify to be around 15, and to a maximum around 45, based on the temperature variation we observed in our chart that is observed here. And we're going to mention some color palettes, so starting blue, green, yellow, and red. So in order to visualize the different contrast of the image, or the highest, for example, blue represents the lowest temperature, and the red which represents the highest temperature, and we're going to output the layer name as Daytime LST 2020. And similarly, to add the for LST night data, so we're going to define map.addLayer LST night 2020 dot clip function region of interest. We're going to set the minimum and maximum value based on our chart value, and we're going to set some color palettes for visualization, and we're going to output as LST, that is nighttime LST 2020. So let us take a look. We're going to navigate to this option called run script and click run script. So let us visualize the result. I'm going to turn off all other layers. So first, let us take a look at the Daytime LST 2020. So you can able to visualize it here more clearly. Yeah, there's a Daytime LST over the study region, New York. So now we're going to navigate to the layer section here. I'm going to click this option here, and you can able to observe here. So we have LST day 1 kilometer, and we have the range starting with 15 to 45, and this represents value ranges from 15 degrees Celsius to 45 degrees Celsius. And we have this custom option, so I'm going to select as stretch 90%, and we've selected the color palette here, and I'm going to click apply to visualize the image in different colors, and you can able to see that. So you can able to view here. So for example, I'm going to turn on this to a satellite mode, and in the layer section, I'm going to adjust the transparency So for example, you can able to see here now. So I have adjusted the transparency of this image. So I'm going to zoom into this study region. So you can able to observe here the highest level of temperature being observed over this particular urban areas. You can able to visualize it. You can able to see that. So the highest level of temperature being observed over the study region, that is over the urban areas. You can clearly able to view that. So in case if you want to visualize the temperature, so you can navigate this option called inspector, and gonna click on this particular image here to visualize the temperature of the particular area, the particular this particular point. So you can able to see here the temperature LST day. So it has 22.27 degrees Celsius in the study region, and you're going to click over this particular area here. So let us observe the temperature over there, over that region. So it is 14.18 degrees Celsius. So similarly, so let us visualize it. This is a 14.1 degrees Celsius. Let us visualize this particular. So it represents the water body. So water body has a temperature of around 14 degrees Celsius. Comparatively towards urban area has a temperature of around 24 degrees Celsius. The variation is around so there is a 10 degrees Celsius of variation between the water and the urban areas. So you can able to see that. And similarly, so you can able to visualize the land surface temperature for the study region. So all this higher, the red color which indicates the higher temperature, going to turn on the urban areas here. So all those urban areas has a higher temperature. So you can able to visualize based on this urban area, extracted urban areas. This is the daytime LST land surface temperature. Similarly, so let us visualize the nighttime LST dataset. We're going to turn on LST nighttime data. That is nighttime land surface temperature. So now you can able to see that. I'm going to turn off this daytime. So I'm going to click this option here. So during nighttime, the temperature ranges from 5 degrees Celsius to 25 degrees Celsius. So it might also indicates minus 5 degrees Celsius too. So let us click this option. So also we're going to adjust some values here. So for example, I'm going to remove these values. So we're going to specify the first value to be around in blue, and the second value to be in the green, and the third value in yellow, and fourth in orange, and last the highest temperature. We can make sure that it will be shown in the red color. And the stretch type, I'm gonna select stretch 90%. And once you did that, yeah, we're gonna click apply, and let us visualize the land surface temperature over the nighttime, during nighttime. So we can able to observe here. So we have the lower level of temperature being observed over this particular area. So for example, so over the urban areas, I'm gonna turn on the urban areas, and let me show you that. So let me adjust the transparency of this layer. So now this is the urban areas, and this is the temperature during night time. And let us take a look using inspector tool. I'm gonna click on this this particular area where the urban area is more. Let us check with using this layer. So I'm gonna place my inspector over this particular area to view the temperature over that particular urban area. So the temperature is around 9.04 degrees Celsius during night, and the LST, that is during daytime, the temperature is around 20.8 degrees Celsius, and during night it has reduced to 9.9 degrees Celsius. And similarly, I'm going to paste it my point here, and let us visualize the land surface temperature over that point. So during day it is around 15.8 degrees Celsius, and during night it is around 5.35 degrees Celsius. And I'm going to paste the point here, and you can observe here the LST during day is around 16.19 degrees Celsius, and LST at night, the land surface temperature at night, is 8.5 degrees Celsius. So in this way, you can able to monitor the land surface temperature during day and night over the urban as well as the over the water bodies in the study region. So in this video, I have shown you the day and night urban land surface temperature analysis using MODIS dataset in Google Earth Engine. So the link will be given in the code link will be given in the description section of this video. So thanks for watching, and make sure that you subscribe to our channel and give us a like.